critical mass of fissionable material. Before that, you have studied about the nuclear fission and the chain reaction of the nuclear fission, and now we will find that what must be the minimum mass required in which the chain reaction can take place without any loss. It is defined as the mass in which the fission chain reaction can take place without any loss. It is the minimum mass. Critical mass is minimum mass of fissionable material. For maximum there is no limit, but this is the minimum one. If the mass is less than this minimum mass, then no chain reaction will take place. So we will have the three kinds of critical mass. Types of critical mass. Number one, the subcritical mass. The subcritical mass. If the mass of the fissionable material is less than the critical mass, let m equal to mass of fissionable material capital M equal to critical mass so if M is less than capital M, the mass of the fissionable material is less than the critical mass, no sustain chain reaction will take place. It means that if the fission starts, then it will stop immediately. So it cannot continue the chain reaction. Second is the critical mass. So now we have this: if M equal to capital M, mass of the fissionable material is equal to its critical mass. The sustained chain reaction will take place. तो जब ये बराबर होते हैं दोनों ही मास, तो इसमें सस्टेन चेन रिएक्शन होता है और इसको अपनी इच्छा अनुसार अपन चला सकते हैं, इच्छा अनुसार इसको बंद कर सकते हैं. सो दिस इज द डिजायरेबल चेन रिएक्शन. All the atomic reactors are based on this concept. All atomic reactors are based on this concept. You have studied about the atomic reactors. There are the controlling rods. When these rods are taken out from the chamber, then the reaction starts, and when these rods are inserted in the chamber, then the chain reaction stops. So according to our necessity, we can start and we can stop this chain reaction. So this is what that is used in atomic reactors. Now number 3, supercritical mass. Supercritical mass. Now in supercritical mass, if M is greater than capital M, if the mass of the fissionable material is greater than the critical mass, the chain reaction is uncontrolled and a big explosion takes place in no time with release of enormous energy. If the mass of the fissionable material is greater than the critical mass, the chain reaction is not controlled. So a big explosion takes place and a large amount, tremendous energy is released in this reaction. This energy is not controllable, so it has the destructive effect. All atomic bombs are based on this concept. What happens in the atomic bombs? There are two or more than two fragments of the fissionable material, each of the mass less than the critical mass, and when this dropped somewhere else, then all the fragments combine together and the mass becomes more than the critical mass. So a big explosion takes place and an enormous amount of energy is released, which causes the destruction of the human life and all the living beings. Everyone of us know about the Hiroshima and Nagasaki, the two large cities of the Japan, where the two atomic bombs were dropped during the Second World War. So one was the bomb that called the Little Boy, in which the uranium was used as the fissionable material, and second called the Fat Man, in which the fissionable material was plutonium. So these bombs, when dropped on these cities, so many thousands or lakhs of the human life destroyed, whole of the city destroyed. So there was no living being, and its nuclear fall caused the destruction of the life to the several kilometers. It has a very destructive effect. So this supercritical mass is a very destructive effect mass that causes the loss of living beings. Now I will tell you the sum of the fissionable material with their critical masses. Fissionable material, and here we take the critical mass. Critical mass. So now first we take uranium 233, 92 233. Its critical mass is 15 kg. 15 kg. Uranium 92 235. Its critical mass is 52 kg. 52 kg. Now this plutonium 238. Plutonium 238. Its critical mass is 9.04 kg to 10.07 kg. This is about the plutonium. Then this plutonium 239. Plutonium 239. It has the critical mass 10 kg. 10 kg. And the plutonium 240. Now it has the critical mass 40 kg. 40 kg. So these are the critical masses of some of the fissionable material. There are other fissionable material also which have the different masses. So this depends upon the atomic number and the atomic mass of this element. So you are looking that minimum mass is for the plutonium-238. This is now 9.04 kg to 10.07 kg. And plutonium-239, this is now your 10 kg. And plutonium-240, this is now has 40 kg. It means that this is the least amount, plutonium-238 and plutonium-239. So a little mass can cause a large destruction. But if we take this uranium, then we have the more critical mass, the 233 as the 15 kg and 235 as the 52 kg. So it is the mass greater than all these masses. It means that a large mass is required for the explosion of the uranium-235 and uranium-230 and this now in case of uranium-235, the critical mass is 50 kg, and in case of plutonium, this is now 10 kg. So this is what that we have the critical masses of different fissionable material. So this is about the critical mass of the fissionable material. So sometimes the question is asked in the examination in which the critical mass is asked, that what is the critical mass of uranium-235, plutonium-238, plutonium-239, plutonium-240. So in that case we have to tell it the answer, because this cannot be calculated at the time of examination. So we have no calculation of this one, but this has been found by the many scientists that this mass is the minimum mass that is required for the sustained chain reaction. So thank you very much.